So we'll go ahead and get started. For the next hour and a half, if I looked at the schedule right, you're going to hear a whole lot about emergency response and 911 and those types of things. So first up, from Datamark, we have Mr. Jeff Ledbetter and also Mr. Mike Rogers with Critical Response Group. And I really like their title, though. It's Planning to Respond and Responding to the Plans. Take it away.
Thanks, Jonathan. Excited to be here with everybody, and most excited to have the slot to speak after Mexican food for lunch. You know, that's a dangerous combination for both you and me. So we're going to get through it together here today, and hopefully we can understand a little bit more about this topic. You know, in the 911 circles and public safety circles with first responders, the topic of indoor mapping is a hot one these days, but I don't think it's risen to the level of the GIO. And so we wanted to take a few of your minutes today and kind of get your eyeballs on the topic and bring you up to speed with that first responder conversation. And the title is exactly that. Indoor mapping is only good if it serves a plan as a plan to speed response. That said, what's the value to the GIO? And we're going to talk specifically about the value to the GIO of these plans to respond that are built upon indoor maps. And then, as Jonathan said, there will be more discussion about that further down the agenda as well. So at this point, I want to introduce Mike. He's our partner over at the Critical Response Group. He's got a really innovative approach. You know, we're here in the Innovation Summit, not the Innovative Summit, but, and you know, as we were kind of batting around this topic, we realized that the real innovation is in the approach to the data collection, the information products that are output, and then ultimately the data that is created that can be used for so many purposes. We've heard it a lot of times already this week. Build it once, use it many times, and we're going to really focus on that today. So I just want to turn it over to Mike at this point.
Good afternoon. Really appreciate the opportunity to be here. I'm going to introduce myself as I kind of go through the slides and tell our story. And again, really appreciate the opportunity to be here today. So the company is called Critical Response Group, or CRG, a company that was formed back in 2016. My background, very quickly, is I come out of 5 generations of law enforcement. So for 130 years, that's what you've done in my family. And I'm ultimately the first one not to do that. So following 9/11, made a decision I want to go in the military, started at West Point, and then from West Point was very fortunate to find my way into special operations, of which I have half a dozen deployments conducting night raids in Iraq and Afghanistan. While serving in that capacity, I was introduced to a very specific mapping technique. In 2016, left that community, came home with the intent of taking what I learned overseas and applying it domestically. And it's a very simple mapping technique. And as we brought the technique home, we were introduced to a number of problems domestically, really in the way that the data is stored today, and from an indoor mapping and a blueprint perspective. And we set forth on trying to solve that problem. Our company is located in New Jersey, but we have individuals spread throughout the entire country. And we have 3 types of individuals on our team. First are individuals with my background coming out of special operations who use this specific mapping technique overseas. 2 are public safety professionals, more from an operational perspective, that help us take our lessons learned overseas and apply it domestically for first response and critical incident planning. And then lastly is a very technical workforce that we have that actually builds the maps and enables integrations of the mapping data into the systems that exist. But where this whole thing comes from was born out of lessons on the battlefield. And to tell a really quick story, but about 2006, 2007, the Joint Special Operations community was told that we needed to increase our ability to conduct night raids. And what we realized as we studied that problem set, one of the primary issues that we faced as an organization was that every night we'd go conduct operations, we would go to locations that we were unfamiliar with. So just like when I showed up to this hotel for the first time today, I was lost getting to this room because it was my first time coming here. Well, that's the same exact problem set that military special operations was dealing with around 2006 as we were trying to scale missions. In order to solve that problem, we came up with a very simple mapping technique called a gridded reference graphic, but the military likes acronyms, so we just called it GRGs, or gridded reference graphic. And that's actually depicted in the center of the picture here, center of the slide rather. And you'll see it if you can see from the back, but it's very simple. It's letters across the top, numbers on the left-hand side, every building is labeled, and every intersection is labeled in this target location. And the imagery is rotated true north. and it's all gridded out, just like a game of Battleship. But military special operations very quickly realized what this enabled us to do, because it simplified the way we communicated, is that it enabled us to increase efficiency. Because for the first time now, when we would go to a new location, we could communicate, navigate, and provide operational command and control in this unfamiliar environment. Well, around 2007, special operations made that mandatory, and every single mission from really the 2007 timeframe until today is still planned using this exact technique. And that's why I have the pictures on the outside, very famous pictures from the Bin Laden operation, because in my opinion, it validates the use of the technique. When you think about the importance of the Bin Laden operation, really the resources we brought to bear as a country, everything was on the table. We could have any fighting force, any piece of technology, but ultimately when you brought us all together at the most important operation of the war, this is how we did it. And we did it this way because it works. So myself, a number of individuals on our team, we come out of that world. I personally have a couple hundred night raids under my belt. I knew that to be best practice. But when I came home, my wife's a school teacher and I have 2 little kids in the public school system. So I wanted to take that technique and apply it to their location. But what I was introduced to was the fact that every school and piece of critical infrastructure in the country has a plan that most likely looks like the binder on the left-hand side of the slide. Now, sometimes we take and digitize that plan, but unfortunately, it's often not accessible nor usable during a time of a critical incident. So as a company, what we really want to do is understand the ground game of what's in place today throughout the states, and then take our experiences overseas and meet in the middle to create a domestic version of the mapping technique. But as we started to do that, we very quickly identified 3 issues that had to be overcome. First is that imagery is always presented to the end user in true north. So north is facing up. So this is a Google Earth piece of imagery, but imagine it's Google Earth, Bing Mapping, Apple Mapping, any of those imagery sources. When we receive them out in the field, they're given to us in true north. But if you take note of the gold star on top of this imagery, as I come from the imagery to this location, to the blueprint, you'll see that blueprint rotates. And the first thing that we identified is that although imagery is in true north, building blueprints are designed on what's called project or plan north, which is arbitrary. So every single building blueprint is rotated in a different cardinal direction based on the architect or engineer who was contracted to build that building. So if we just simply take that data and put it on file, the graphics aren't even oriented in the same direction. That's problem 1. Problem 2 is if we talk just schools, school buildings themselves, the buildings are on average over 50 years old. That's 50 years of changes, renovations, and additions. So if you just simply take this information and scan it, you're scanning inaccurate information. So it's very important that we fix the ground information. The example that you're looking at here, the building, as you're looking at it on the top right where it's the basketball court, now this building's about 12 years old. That's no longer the basketball court, it's actually the cafeteria at the school. But these are the floor plans that we pulled from the local municipal police department when we started the contract. So problem 2 is all the data is unreliable. And problem 3 is the blueprints are rarely labeled to reflect the nomenclature of the facility. And by that, I mean, if you look at this and I ask you to go to door 5 or classroom 2, you can't use this to help yourself when you're navigating or communicating because no one took the time to write down that label. So as a company, we fix those 3 problems. We standardize the orientation so they're all true north. We make sure they're accurate. We walk every facility and correct the base information. And then lastly, we label it to reflect the nomenclature of the facility so everyone can talk about it. I'm going to show a quick animation. What we do is we take whatever's on file, cut it out, rotate it so it's true north on an up-to-date piece of aerial imagery. We then walk the structure with engineering software and we correct the base schematic. So if that facility has moved walls, moved doors, changed anything as we're going through on site and verifying it, we're having now an accurate accurate base layer. While on site, next thing we do is we gather the site-specific labels to match the actual physical structure. So if it's classroom 2 or door 5, stairway 15, or conference room 6, our labels match the physical location, enabling everyone to communicate very efficiently about the specific location. Next thing we do is we work very closely with the facilities and securities teams to identify all the critical features of the structure. So namely a fire access control panel, a gas shutoff, an electrical disconnect, an AED location, a camera location, anything that would be important from a response perspective that gets marked on the graphic. And then the last thing that we do is we overlay that very simple gridded template that really leveraging the lessons learned in the military. And the reason that we do that is because it enables everyone to communicate in a very efficient manner. And I will demonstrate. So now what you're looking at is instead of a GRG, that gridded reference graphic, which is the military version, you're looking at a collaborative response graphic or a CRG, which is the domestic version of the mapping technique. But if I orient everyone, so north is up, and I want you to go to the northeastern part of the building, so top right. I know it's probably difficult to see in the back, but if I oriented you to top right, I want you to find grid square J4, Juliet 4. So you find J on the top margin under the word Eagle, 4 on the left-hand side, play a game of Battleship with me and come to grid square J4. And in there, you'll see door D, door Delta. So now I want you to come to door D, come onto the black hallway, make your first right, and meet me in the media center. I doubt anyone here has ever been to Brielle Elementary School in central New Jersey, but I just put everyone through a very specific breach point, a specific part of this building in about 10 seconds, and you've never been here before. And ultimately, that's all that we're trying to do is flatten the communication. So independent of jurisdiction, discipline, level of training, everyone can now communicate, navigate, and work together at a facility that they've most likely never been to before. When we build maps, we build 2 types of maps. First, we call it a macro. Just think of it as a high altitude command and control graphic, really just the exterior shot of the structure. But I show this because we don't just create very simple pieces of imagery that are gridded out. It's a very smart piece of geospatial intelligence. We use a very specific piece of military mapping technology. We're the only ones in the country with it. And what it enables us to do are 2 important things. 1, replace out-of-date imagery with new imagery. So I can take imagery and exploit it from any collection platform. So any satellite, any drone, any aerial collected imagery, I can take that together and stitch it together. But most importantly, when we do that, it enables us to embed the latitude and longitude in every pixel in this piece of imagery. And because now that base imagery is smart with an embedded latitude and longitude, when we go on site and get the blueprints that are usually rolled up in a basement somewhere and we run them through our workflow, the blueprints now retain those geospatial properties. So because the underlying imagery is smart and run it through our process, the blueprint retains that information. That's important for a number of reasons. First, when we go and upload this information into, let's say, Rapid SOS, I can now geolocate a 911 caller internal to a facility. When we put this on a mobile application for a first responder, independent of jurisdiction or discipline, the responders can track themselves interior to the facilities. Also important to point out is on the northeastern part of this building, on the top right again, it's a grid square I-5, and I know you can't see it, but insert in grid square I-5, there's a door numbered door 9, and it's labeled green because that's in accordance with the national standards, but I'm gonna start at door 9, and I'm gonna go to the north. It goes door 9, 10, 11, 12, 29, 13, and the doors are out of order. Well, the reason for that is at this school, the doors are out of order. Unfortunately, that is not uncommon. As we go across the country and look at the labels of the facilities, there rarely is a standard in place. And even when there isn't standard in place, we find deficiencies like this every day. So that's why it's extremely important that you go on site, you get the correct information, we can have reliable information so that those that are making life-saving decisions are making out of the best information possible. Traditionally, what we start with, if we're lucky, is an architectural drawing that looks like this. But again, this was designed to build a building, not to enable more efficient instant response. This graphic goes back looking like this. But the same exact school district that had a really good schematic that we used to make this, another school 2 miles down the road transmits something like this. We've done, about 7,000 to 8,000 buildings across the country today. Less or more than 11% of the schematics we see look like this. It's either an abstract drawing, it's a hand-drawn schematic, or they're not able to produce anything at all. So it's a tremendous issue. All the 90% of the other information is mostly wrong, but a lot of times we get something like this that's not usable at all. We take this information and it goes back looking like that. So now we're standardizing the data and fixing the problem so it's in a more easy to understand, reliable. But in this example, you'll see that the doors are identified, but they're not labeled. And the reason for that is because when we initially walked this facility, there were no labels associated with the doors. We will not make up a label. Our maps match the facilities. But in this example, and in all cases, we work very closely with public safety. And public safety is always the recipient of our graphics. And what the byproduct of that is when we go and hand this to the municipal police, fire, and the county sheriff's office and the state agencies, their first question in this example is, why are the doors not labeled? Well, it's because they're not labeled. So as they make a recommendation on how they want that facility to be properly labeled, we come back on site, rewalk, relabel, redisseminate the graphics. Our intent being is that as the facilities continue to change and they update and we find deficiencies and fix them, the graphics are up to date. Everything I have showed up to this point has been public schools. That's really the moral underpinnings of the business, but also because it's part of our business model, that's really what we have found that is able to unify public safety around this content. But the same exact technique that applies to a school also applies to a place of worship. I show this for 3 reasons. 1, it's a place of worship. 2, it's more of a campus style setting, but it highlights the problem that we see every day. The building on the top right is about 100 years old. The building on the bottom left is about 10 years old. So when we were contracted to build that project, they gave us a rolled up set of blueprints and a thumb drive. But imagine we try to give that to a responder during a critical incident. That's an unrealistic expectation that they can take that data, ingest it, make a decision with it. And ultimately, that's what we see every day. We're able to take it, ingest it, fix it, and send it back in a very easy to use format. This is a government structure. It's a third floor of a government structure. And I show this because it's very important that as we go vertical in the structures, each floor, imagine you have this two-dimensional slice for each floor of the structure. It's a very large hospital complex in New York City. So it doesn't matter if it's a rural school district or a very urban environment. This one was, imagine you had a jigsaw puzzle of all different file formats. So because the building had grown so much over the last 100 years, part of the building was given to us on rolled up drive, on a thumb drive, part were scanned PDFs. Sometimes there were hand-drawn sketches. We take all of that data in, stitch it together, verify it, walk the facility, label it, and then ultimately import it into the tools used by public safety. And I think that's what's so important. When you look on the bottom of this, you'll see the NYC BIN, which is the New York City Building Information Number. That's because we work very closely with the police department in New York City and the fire department in New York City. That's how they categorize their buildings. So because we work with public safety, we want the data to be on file, and it's easy to be found when they need it in a time of critical incident. That's the second story, or the sixth story of that structure. Milwaukee Brewers Stadium, we've done a tremendous amount of mapping in the city of Milwaukee, and that's what you're looking at right here. Great, real quick use case on it was when we met here, the security director, the police department, the fire department, the facilities team all showed up and they all brought different maps for the same facility. So we're able to take all that different information, bake it together, and create a single graphic that they all agreed upon. An airport down in Florida. And I show this really because the technique applies across the board. We're mapping across the country and the type of facility really doesn't matter. What we're advancing and the problem that we're working to solve, if this allows me to advance the slide, is the problems that we see in the specific states are highlighted on the left-hand side of the slide. And we understand this because we've just been doing this for a number of years, is the floor plans in any one of your states unfortunately look like the far left-hand side of the slide. Some structures have rolled up schematics. Some have, they're in literally, hidden in a binder, CDs. Unfortunately, they're just sitting in a lot of different file formats that cannot be ingested by public safety. So first thing that we do is we go building by building and find the appropriate information. That's step one. Step two, because everything is in a state of disrepair, 99% of the source data that we see is incorrect. It's all wrong. So we have to go on site, gather that information, correct the information, label the information, and create this graphic. And most importantly, the last piece of what we do is the dissemination of it. What we've seen is that the fact there's, and you know better than I, the lack of interoperable systems that are deployed throughout public safety. In an attempt to create a common operating picture, we've come at the problem from a totally different angle. We want to work with public safety, understand what technology that they have deployed, and ingest the maps into those tools today. If what we see every day, talk about school panic buttons and extremely important, great tools, but a lot of times we're requiring police departments and fire departments to come off the tool that they use every day into a tool that they're unfamiliar with. Again, I believe that's an unrealistic expectation to make them do that during a time of a critical incident. So we work with public safety across all sectors and disciplines to understand what they need and put the map into the appropriate format so they can be ingested into the tool that they use every day. What that looks like in practice is right here. So I'm going to start at the top left and kind of walk around just highlighting some of the locations that we put it. So first and foremost, top left is our integration with Rapid SOS. We work very closely with them where any building that we map, every map gets automatically uploaded into that tool. If someone calls 911 from a building we've mapped, that data is instantaneously presented to that PST with the caller location pinned right on top of it. So now we're able to get indoor positioning. We're working very hard to get the Z-axis information, which I'll show in a second as well. So now we can plot on the X, Y, and Z internal to a structure. Top right is an example of a school panic button. So anything from Raptor to Rave to Crisis Go. Perfect example, I was on with Palm Beach County down in Florida a couple days ago with their Peace app. They have 9 different panic buttons throughout the school systems throughout Palm Beach County. So now we're asking public safety to be familiar with 9 different tools. So what we do is we're able to take the data that would go into that map, that mapping data that would go into the police department tool, and put it into all those 6 different apps that the school districts have. Bottom left is the CAD integrations, and then on the far bottom right are mobile applications. Mobile applications to increase situation awareness are growing very quickly within public safety. 2 that are important. One in the center is called ATAC. ATAC stands for Android Team Assault Kit. That is deployed by all the federal partners. So FBI, ATF, DEA, they use that every day. Our maps go into that tool. And then just to the left of that is another mobile application called GXP On Scene. That's deployed very heavily in a number of states. So, in the state of New Jersey, about 2/3 of public safety have it on their phone. Wisconsin, that's deployed very heavily. Florida, that's deployed very heavily. There's a number of other states that are in the beginning stages of that, but that information, or that mobile app rather, enables officers to see themselves in real time and get access to the data in real time. And that's just a quick snapshot of what it looks like during a drill a couple months ago. So on the far left, you see all those little framed out pictures or framed out boxes. That's just a location of the data. An officer can very quickly, securely authenticate in, grab that data, see themselves real time, other responders in real time, and have access to it. One of the last things I wanted to touch on is we've seen a tremendous amount of momentum in the last, I'd say, 24 months of the importance of the Z information. So as we're going on site, because we're actually going on site and collecting the data, we've now taken it upon ourselves to collect the Z information associated with each of the floors that we walk. So we have a partnership with a company called NextNav. We use a couple other tools, but as we're walking that structure, it's enabling us to collect both the height above ellipsoid and height above terrain. And we embed that mapping information into the graphics. So that's what it looks like when you take, the two-dimensional, I think you have a two-dimensional map with a Z property, we call it a CRGZ. It's two-dimensional, so it's simple enough to be utilized by a responder under stress, but it has that Z information so we can take it to the next level. And just another example is when you remove the 3D modeling, that's what's left. That's just what it looks like when displayed in, I believe it's in Google Earth. So with that, I'm going to turn it over back to Jeff, but the last thing is, CRG is not a GIS company. We don't pretend to be a GIS company, but we've partnered with the best one out there. So what we've done is we've been able to take our two-dimensional data as we're going out there collecting it, but because we do not do those geospatial files, we hand the raw data, the CRG, over to Datamark, and they're able to take that information and transition it into the traditional geospatial files. So with that, sir.
Thanks, Mike. I've been working at the intersection of public safety and GIS for the last about 12 or 13 years. And the conversation that I always had to have as the GIS professional among those 911, first responders, and police, fire, EMS, especially their managers, was the difference between, I didn't advance, there we go. The difference between maps and data, right? What they look at are maps. These collaborative response graphics are in some cases kind of like maps, kind of like indoor maps, right? But you may be used to seeing this curve sort of reversed a little bit, right? Thinking of data moving into an information product and then being consumed or sent out to consumers eventually. It is this distinction of the data itself that we come to make this response to the plan the interesting part that we begin to explore the value to the GIO. And so in this case, as information is created and gathered, the real approach, again, innovation comes into, in my mind, that idea of flattening communication, collecting the information and correcting the data. So we create data from information in this case and put it out to consumers, not only in the format of these CRGs, these collaborative response graphics that are very useful and approachable for first responders, but also in data format, right? So what's the value to the GIO of this interesting data? This is like really granular local data that GIOs are probably thinking, I can't handle at a state level, or maybe there's not any use for this at a state level. The part that we haven't talked about yet is that there are things like Alyssa's Law in Florida and variations of that similar legislation in 8 other states, including Wisconsin, where we're at today, where there are actually now regulatory requirements to create plans like this, especially for the school building use case, but also in the case of other critical infrastructure and key resources. I worked in San Diego for a while under a UASI funded project where we created a lot of these response plans. We did them in GIS, and it really was difficult and hurt a little bit to kind of figure out how to do that. But this idea of taking this GIS data that is this very granular level and making it something that a GIO can use and serve out to a useful audience would definitely go beyond public safety first responders, right? But it would primarily include that. Your support of your EOCs or your 911 centers that we've talked about in a couple of presentations this week is another place. Common operating pictures that need to occur. You can extend that same data to talk about broadband availability, transportation modeling, climate change modeling, all these topics that have been brought up this week. The fact that you have floor plans, indoor maps, response plans applies to those things as well. And decision support systems are all about that. But having the GIS data that you can put into web apps, maps, and other things is where the value is for the GIO. So we want to bring that to your attention that it's likely coming your way that these response plans are going to become mandated. Wisconsin's a good example where the legislature here even put funding in to create them. And so now you have an opportunity, if there is a statewide approach to this, to collect GIS data, required GIS data even, not just sort of response plans, but things that we can extend into all the other applications that you can imagine. And so the transition from information to data multiplies the opportunities to do that. That's not a concept that I would have to explain in detail to this audience. You guys understand it. And again, I've said it all week long in almost every presentation. Build it once, use it many times. It's a valuable investment, and we want to capitalize on that investment. And so you have an opportunity here. We talk about data supply chain in terms of 911 data, roads, center lines, address points, boundaries. That data supply chain has to start at the local level, but then there has to be quality checks and quality assurance that occurs at every level, so that you can capitalize on what's been made available. So that's what we wanted to present for you today. We'd be glad to take any questions if there are any and discuss this topic.
Thank you, Jeff. Any questions in the room? Oh, didn't even get settled on the side over here.
Yeah, great presentation. This is Richard from Texas. And first of all, Mr. Rogers, I wanted to thank you for your service for sure. We all know we're much better off with people like you in the military, so thank you. So this is a great strategy, which actually quite impressive. I didn't realize y'all could do that into this way, but my question really has to do with, once you create the data, is there, the issue is, I guess, keeping it maintained maybe becomes really the real big part of it, at least in my mind. So is there a plan, or how does it work? Two questions here. How does it really work to keep it maintained? Is that something you have to keep going back to, or is there just a philosophy of we made a room change, we divided a room or took out a room or something, and that goes back and then that gets updated? And then the other part of it is do the building owners have access to these plans? Is that just an understood thing, or do they sometimes just not even have the floor plan and you guys have to come in and kind of remap the internals?
Great, two great questions, sir, and thank you for those. When it comes to changes, on a minimum, we walk the structures on an annual basis. And really the problem that we saw is initially when we were doing it, our whole intent was to be one and done and just move on to the next location. And then we saw structures coming back 2-3 years in and saying, hey, we've relabeled everything. We fixed the changes that you identified. And so we saw the same problem that we were trying to solve initially. So we got very lean in terms of how we go back and walk them on an annual basis. If it's a location that changes more frequent than that, the private sector locations, the Javits Center is a perfect example in New York City. Every time that location changes, we're making a new map from. So as that goes from the car show to the tattoo show to the flower show, our intent is that when someone picks up the phone and calls 911, they're not going to say that they're at section 123 on the map. They're going to say, I'm outside the Toyota booth. Right. We want to bridge that gap from a communication perspective. So in that example, we're doing 2 maps, 3 maps a week for that specific location. Perfect examples from the state of Texas. We had just mapped Midland, Texas, the unfortunate school shooting that happened down there prior, maybe earlier or at the end of last year, sir. And the mapping data was on file with the municipal police department, fire department, and the county. Texas DPS did not have the mapping files at that point yet. So we got called 15 minutes into the event. DPS hits us. We present them the data electronically. They're able to upload it into their CAD system. Then every trooper had it in a matter of about 20 minutes into the incident. And what that is fed from there is the hostage situation that happened at the end of last year, or is this year or last year in the synagogue. We were called about 25 minutes into that event. And the only thing that they could get, to your question, your second question, was the old floor plans, like off the side of the wall, the fire evacuation plan. Not to scale, not accurate. So our source data that we started with was literally like a paper copy someone took with their phone and sent to us in the middle of a stressful situation. Not the best place to start from like a data starting point, but we're able to take that, enhance it, make it a scale, and push it back out to the responders, and they were able to get it in the systems that they had. So when it comes to the building owners, the intent is that data is going back to them, it's going back to the building owners, because they have a number of systems that they're using. They're going to have video management systems, they're going to have access control platforms, they're going to have panic buttons if it's a school or place of worship potentially. Our intent is that the mapping data is in that tool, but it's also in the CAD, it's also in the call handling system, it's also in every tool that someone could show up with, they have that same data. So the way we approach the problem is I don't care what piece of tech you show up with, because they're all going to show up with different tech. But as long as everybody knows where door 5 is, it enables everyone to communicate in an efficient manner.
Do you see people being more proactive now, kind of with the world we're in, to be more proactive about updating their floor plans and giving it to a organization like yours to keep it maintained? Or is that still like pulling teeth at this point?
We are seeing a tremendous uptick in our specific offering. Our business has doubled year over year for the last couple of years. We're the only ones doing anything similar, anything really where we're going and actually verifying the data, putting it into the formats that are required. So we've seen a tremendous uptick. But when you go into any state, if there's an educational campaign, everybody looks, and I give a very similar presentation that I just did here. It doesn't matter if it's a sheriff's deputy or a sheriff or a school district, it's the same thing. Everybody looks at it and says, well, of course I want to have accurate data on file with public safety. So no one pushes back. It's just a matter of educating them that there's a problem. And we saw that exact issue when we started the business. Initially we were just putting grids on imagery for a building. And we would label it like we did in the military. There's no labels in Iraq or Afghanistan. So we label them like building 1, building 2, building 3. You come home, there's a really well-established labeling convention for the structures. So we had to pull that in. So we started this business. I didn't know the problem was. So it's a matter of educating everybody.
Thank you.
Thank you, sir.
Yeah, I was just going to mention that, as you're going through that, what you're doing there to create that common operating picture, situational awareness, those types of things is just really awesome. And by the way, I really thought that graphic that you had in there with the building and the maps, sliced through it at every floor, that was a really cool graphic. Anyone else in the room? And Jamie, I'm not in front of a screen right now. If there is any, we got one question in the room, but after this one, Jamie, if there's any in the chat.
Marianne, Indiana. I used to work with airports quite a bit in a previous life. And so their floor plans changed tremendously, probably closer to what you mentioned with the Javits Center. United Airlines may have one desk one day and now there's another space being used. There was a mention of using, create the data once and use it multiple times. So in a lot of those environments, the square footage of each room becomes very important because that's how they determine the cost of a lease and things like that. So with the idea of using it once and creating the data once and using it for multiple applications, are there ways for you to intake data that may be managed with CAD in terms of AutoCAD, not the public safety thing, or GIS data sets, and then still pushing the data into those various systems that you mentioned today?
You want to take that one? Yeah, I think there's absolutely opportunity to do that. And that's exactly the value to any GIS professional. And as it aggregates up to that GIO level, that's the opportunity, right? Is to use that sort of, especially in the skeleton case or the Javits Center and airport are great examples where there's a shell that always remains constant, even though there's partitions that are put up or taken down or booths that are constructed or deconstructed. If you identify those in the GIS data, then they can certainly use that, cement that use case And I think, as you pointed out just a second ago with Richard's question, the maintenance of it and, you know, the correction of the information that's found on those plans on the shelf or those rolled up blueprints that aren't very useful in that sort of space inventory management systems. You know, colleges, universities are definitely high on the list of entities that could use good GIS data about indoor spaces for space and inventory and management as well. I have something to add to that.
Yeah, thank you. So one of the big things with airports, to exactly to your point, man, they change so often. So we're mapping Dulles and Reagan airports right now. We're always, you know, Dulles and Reagan Airport, you would think as a company, we're high-fiving each other that we landed that contract. What we see every time is that before that project's even complete, the base work that we had started 3 days ago, they're calling us and saying, hey, we just redid this and we moved the Nathan's hot dog from here to there. So it's continuously changing and evolving. And to the earlier point in your question, when we start a project, Dulles and Reagan being another great example, part of that building was transmitted to us in CAD file in the DWG. Part of it was transmitted to us as a scanned PDF. And then they, like the architectural drawings and a rolled up blueprint, because they had to build that part of the building, is being transmitted in a different way. So we're able to take, and that's really the problem that we solve when you bake it down, is whatever is out there in the world, we can ingest it and then ultimately put it back out kind of at the back end of the funnel and the tools that public safety or, you know, a facilities manager would need to utilize. Thank you, ma'am.
Anyone else in the room? When I checked the chat just a couple of minutes ago, there was nothing in there at the time, but Jamie, anything in the from the virtual audience?
Jonathan, I don't see anything in the chat at the moment. I'll keep an eye on it.
All right, we have one in the room.
Rich Wohler from GPI. This kind of dovetails to some of the other comments. One of the biggest emerging technologies is BIM and Revit technology, which is essentially fully scanned rooms, structures. Have you had any thought of integrating your work with that type of work?
Great. Yeah, very familiar with BIM and Revit specifically. Great piece of technology. I think for the public safety community, it's too much information. You know, with my background, there becomes a point where it's too much data to drive an intelligent decision. That's why I was talking to a very close friend of mine who's at Delta Force yesterday. Are you using 3D stuff still, or are you using 2D stuff? He's like, today we're still using two-dimensional. Unless we're landing a helicopter, we're not going to touch the 3D stuff because it's too difficult. That said, we can ingest our mapping data into those. So we can put basically just like that 3D, you go back a couple slides, where I can take and embed our information into that BIM system, where we're basically just the verified, you know, XYZ floor plan that's going into that. But we see there's a number of companies that are out there trying to provide that data to public safety. And unfortunately, what we've seen is that one, the data sets are too large. So I can't transmit across a degraded network during a time of a critical incident. And it's just too information. The responder, when they show up, they don't care necessarily what this room looks like. Their training is going to take care of it when they get, but they need to know how to get here. What stairway do I take? What elevator is going to be most efficient for me? So it's getting them from point A to point B as efficiently as possible. But one, I can't even get them the picture of this room if I wanted to. And if I wanted to, they would never use it.
Anyone else?
I was going to say the last thing really, the work, we understand the ground game in terms of if it's too expensive, it can't be accomplished. So we worked, and a lot of times what we'll do in the state of Texas is a perfect example. The school districts are procuring the services, the places of worship are procuring the services. And a lot of times that data will go back to public safety at no cost. And, you know, same thing in the state of Wisconsin, you know, up to this point, there's been 400 schools that have been mapped, you know, plus Oshkosh Defense, Molson Coors, the Brewers, the Bucks, all those stadiums have been mapped to go back to public safety. And then what happens is kind of a natural day too, is public safety and the state look at it and say, okay, we've started to standardize a tremendous amount of this data. We now want to help participate. So there's multiple different funding sources, different grants that we're able to kind of spread the cost throughout an entire community. So, but it's really just this movement, this idea of getting behind that we want to have current up-to-date data. And once we all agree on that, I think it's pretty easy to find a way to accomplish that.
Thanks a lot, Mike. Jeff?
Thank you, everybody.